This is the Art of Network Engineering podcast. In this podcast, we'll explore tools, technologies, and talented people. We aim to bring you information that will expand your skill sets and toolbox and share the stories of fellow network engineers.
Welcome to the Art of Network Engineering. I am Tim Bertino at Tim Bertino on Twitter. And buckle up, because from the A1 side, I will be driving the ship solo for this episode, you poor souls. That being said, we don't do too many episodes without a co-host roundtable, so what I think I'll do quick is just predict how it might have gone down this week. I'll say AJ would start with me. I'd try my very best to say as little about myself as possible. Then Dan might send a zinger or two toward Andy. Andy would probably give a most elegant retort, and finally, Lexi would probably tell Andy to watch his mouth, and AJ would just try to keep everything together. There, I think that went quite well. Now, never fear, I will not be talking to myself the entire time. This week, we have a sponsored episode brought to you by Augtera Networks, the first network AI for the modern enterprise. And joining me from Augtera is founder and CEO Rahul Aggarwal. Thank you so much for joining me, Rahul, and for your support of the Art of Network Engineering. How are you?
I'm doing well. Thank you for having me on the show.
So, Rahul, we are the Art of Network Engineering. We are very passionate people about the technology, everything in play across network infrastructure, but we are also very passionate about the humans behind the technology and the people behind everything that makes networks go. So if you wouldn't mind taking a few minutes and give us a background on you. What got you originally interested in technology? What have been some of the different roles that you've held? And then ultimately, what brought you to create Augtera?
Yeah, so just in a nutshell, I've been a technologist most of my life. I got my bachelor's from the Indian Institute of Technology. Then did my grad school in University of Minnesota in computer science, and got into networking. Spent my early years at Four Systems, and then at Sierra. Went on to Redback post the Sierra acquisition, and then was fortunate enough to be at Juniper for a long time, where I co-created several industry-changing technologies, both in the MPLS and the VPN area. Multicast VPNs, MPLS multicast, and then more recently after that, EVPN, which is now very, very widely deployed in the data center. Started my first,
wow.
And then after that, left Juniper, started my first startup, which was in the content analytics space. That got acquired by a company called JanRain, which then Akamai acquired. And after that, I really felt that my heart was in networking. That's really where my passion is. Saw an opportunity and a big gap in the landscape, and that's how Augtera started.
That's exciting. I will say that you have been incredibly busy in your career. That's really interesting. One of our co-hosts, Andy, that I mentioned in the intro there, he is now I think just under a year now been employed by Juniper. So that's quite the story. So let's jump right into Augtera. What is the base platform to Augtera, and what does it do for its customers?
The gap that we saw in the market or in the landscape is that essentially there is a whole movement of big data and machine learning, which has really transformed multiple industries in the last 15 years or so, but networking has really been left behind. There are a lot of tools which exist for network operations. There's so many different companies, so many tools, but really they follow this old paradigm where there's a lot of data, they collect the data, often with poor fidelity, but whatever data they collect, sometimes high fidelity, often poor fidelity, it ends up in this massive data haystack, which humans manually mine. So anything goes wrong, it's often the applications and the customers who complain. The network operations teams then scramble to figure out what went wrong, where, what the root cause is, all of that. So, and what we set out to solve was to really bring predictive and early detection capabilities to that environment, where we apply machine learning to see what's actually going wrong well in advance before it does. So the operation teams, instead of having getting a call at 2 a.m. in the night, they can actually get ahead of the problem, or well ahead of the problem, and fix it in advance, and do this across all very large scale environments: data center, hybrid cloud, public cloud, SD-WAN. Do it in a way where the problems that you find and solve in the network are really application impacting. So you can really connect the dots from the application layer to the networking layer, and really make sure that what you find, what you solve, it's has a very direct tie into the business continuity, to the revenue. So that's really what the problem that we solve, and we have a platform which solves that, which I can talk more about.
Yeah, that'll be excellent. I will say from my own experience, so I've been in network operations, network engineering for most of my career and in the enterprise space. And I can definitely relate to that being an issue, because I will say that even today, and especially up until recently, network operations, network troubleshooting has been and in some cases continues to be a very manual process. It's very difficult. It can be very, like you said, very reactive. We essentially sometimes, and maybe more often than not, don't know that there's a problem necessarily until somebody picks up the phone and reports that problem. So I definitely agree with you that that's been a gap, at least in enterprise networking, that we always seem to be in a reactive space. So what is Augtera doing for us to help us become more proactive in network operations?
Yeah, so see, at a high level, what Augtera does is we take data from literally any data source you can imagine, and I'll talk more about that in a minute, and from any part of the network you can imagine. We take this data, we normalize it. It goes through a very sophisticated software stack, which can be deployed on a set of VMs, either on a customer's premises or consumed as our SaaS service. And this data, it goes through our machine learning pipeline. And very importantly, the realization that we came to is that we needed to build purpose-built algorithms for the network, and that using off-the-shelf commodity algorithms was really creating a lot of false positives. You really need a very domain-specific approach. So we've built a whole set of different algorithms for different metrics, different algorithms for optics, for temperature, for traffic, for congestion, for TCP, for latency, for application loss. For logs, we have completely different natural language processing algorithms. And what we do is we figure out changes in patterns without humans telling us what's normal. So we really automatically figure out, for example, one of our customers, the temperature started to creep up on one of their units out in the field. And they got a notification automatically using our anomaly detection that the temperature is now misbehaving. Then that was a trigger for them to really start looking at the graph, start looking at the data. And they realized, yes, that unit is actually misbehaving. It had been stable for months, and now it's not. So they dispatched a field unit to take a look, and the air conditioning was broken, and they were able to put a temporary patch in and avoid an outage. Another example would be, suddenly there are ASIC parity errors which show up on a switch, and our log-based AI, which uses natural language processing, can look at billions of logs and surface what's anomalous and unique in real time, which you haven't seen. So all of a sudden, you will get this automatic notification which says, you know what, you've got this ASIC parity error. And lo and behold, that means something is wrong with the hardware. And now you can go and fix it, reboot it, talk to the vendor. So it's cases of that nature. Or in public cloud, all of a sudden you find that your latency across VPCs is spiking. And if that latency across VPCs is spiking and it's no longer normal, then, well, maybe you need to go and talk to the public cloud provider, or maybe, because they may not even, listen to you, at least you can move your application workloads and avoid them, getting impacted. So on and so forth. So essentially, we apply all this machine intelligence to find these what we call anomalies with very high fidelity, low false positives, and very, you can say refined, so that there is no alert fatigue. And we also are able to automatically correlate them and do the correlation across layers, across the application, across the network, which I can talk sort of more about. But that's, that's in a nutshell how our platform works.
I'm glad you brought up alert fatigue, because that's definitely something that I think is an issue. I think we tend to want to make sure that we have every piece of information possible. We never want to miss a problem. And then all of a sudden we get all of these alerts coming in that we either mute a number of them, or we create rules in our email to dump certain ones into a bucket that we never look at. So I think that's really important, and maybe we can touch on that a little bit more on how you specifically handle some of that alert fatigue. But where I want to start, I think, after hearing what you just discussed, was let's start with the data. You talked about, so let's say I'm an enterprise customer. I have a few VMs that are going to be collecting this data on the Augtera side. How am I getting that data from my network devices to Augtera? Am I doing syslog? Am I doing some sort of streaming telemetry? How do I get it aggregated in the first place?
Yeah, that's a really good question. And that part of our product has significant engineering that's gone into it. I wouldn't call that part of the product as the secret sauce, but it is not to be by any means undermined, because it's a very, very complex engineering problem. So what we do, I'll take you through it slowly. First, let me give you sort of the big picture. We can take SNMP data natively. So we can, take essentially we've built, and the entire stack is end to end. It's self-contained. So we can take SNMP, we can take syslog, which are both widely deployed, as we know. We can take OpenConfig and gRPC, which is what the world wants to move to, but has failed to do so for the last decade. We can take SFlow, IPFix. So essentially, we cover everything from topology to system metrics to, you can say, interface metrics to events to logs, anything you can imagine, across all forms of standards you can imagine which exist. Then you get into proprietary APIs. We have a mechanism to take JSON encoded data, and that data can be sent to Augtera using Kafka or using our API. So we can connect to a Kafka bus, and that JSON encoded data can be completely proprietary. It can be specific to a customer, to an enterprise. It could be specific to a third-party tool, and we can dynamically normalize that data, using configuration that a customer can provide. We also have so these are all the data sources we can take. So we can take VPC flow logs, logs in the cloud. We can take any other form of JSON logs. Then, in addition to this, we have our own agent, which can be deployed purely for synthetic probes for latency and loss measurements across public-private infrastructure at scale with a high degree of fidelity. Now, so it's a very wide range of data we take. The other thing is we have significant engineering on making, for example, SNMP scale. We can poll tens of thousands of endpoints, switches, or servers using SNMP with a very cost economical in-house SNMP implementation. At the same time, we have a highly economical big data implementation for telemetry streaming, IPFix. We can take hundreds of millions of logs an hour and do real-time analytics and prediction and machine learning on them. So, hopefully that gives you a sense. So it's really, our goal is take literally any sort of data source that you can imagine, and really, that's critical. If you can't take all the data, one of the problems in this space has been there are a lot of tools which have tried to optimize single data sources. Maybe it's SNMP, there's a tool, maybe SFlow, there is a tool, IPFix, there is a tool. That sort of that's a completely broken model. And it gets more and more difficult to even maintain or manage that model in today's world. We are completely changing that.
That's really interesting, and I want to key on the topic where we were talking about being reactive versus proactive, and you brought something up that I thought was really interesting, and you said that you have an agent that can go on devices to do synthetic testing, which I think is really important because you constantly, for performance reasons, you want to be testing applications, you want to be testing performance at all times, and to have an application, an agent that's doing that synthetic testing, I think is a really interesting piece of the puzzle. So what kind of operating systems, form factors can that agent run on?
Yeah, so our agent is highly optimized to take, consume very little memory, and it can run even with, about one core available to it, one virtual core, and a few tens of megabytes. It can be as low as that if needed. It's a Linux binary, so it can be run on any environment as a Linux binary, either on bare metal, on a VM, or it can be containerized. We've got customers running it on switches, which are Linux switches. There are plenty of switches which support, or are friendly to Linux, and we can run our agents on those, or on servers, or on VMs, on the servers, or on VMs in the public cloud, or for that matter, containers, in the public or private cloud. So it's a range of environments and a range of use cases. So you can check, for example, is my latency between AWS and Azure, is that beginning to misbehave? Is my latency from a private data center to public cloud, or from within the data center across my servers, is that latency beginning to misbehave? And then if it is, or am I seeing significant packet loss between two different availability zones in my private cloud or within one? And is that correlated to packet drops which are happening on a switch? Because Augtera can actually get the switch packet drops using SNMP or gRPC GNMI streaming. So that's when it starts to get interesting, when you can really use the agent. So there are other people who have agents. I think where it gets interesting is having agents at scale. That's a tough problem, both from technology and economics point of view. Second is you have so much data that agents produce. You go back to our basic thesis that you need machine learning to tell you when that data is misbehaving. And once you know that you have this, loss which is suddenly misbehaving, well, how do you know what's the cause? Where is actually the root cause for this loss? Is a switch dropping packets? Is a hypervisor dropping packets? Is there some congestion on the top of rack to server link, so on and so forth, right? So we use synthetic testing as an important tool in the puzzle to bring it all together.
Wow. Okay. So I think I want to jump into that a little bit more. And we initially talked about, ingesting data from these devices and seeing, if there are specific issues with a single device. But a lot of times like you said, that path monitoring, you want to see any potential thing in the path that could be causing an issue. So can you kind of help us paint the picture for how, obviously not getting into the secret sauce, but how Augtera takes all of this data from different devices and sort of, is it internally painting some sort of a topology to see how all things connect and be able to show where in a path there's an issue, or what does that look like?
That's a very good question. See, the one thing we didn't talk about so far is actually your question sort of makes me talk about a bigger topic, right? What is network specific about Augtera, right? I mean, some of the things we're talking about. So networks, the semantics of the network has a lot to do with topology. It's not the only thing, but it's a big thing, right? Understanding the protocols, layer 2, layer 3, BGP, SD-WAN, OSPF, ISIS, you name it, right? So we auto-discover the topology of the network. So we actually understand the topology and the connectivity of the network. We are able to visualize it. We are able to build a model out of it. And we use that to really understand that if packets are going from server A to server B, what are all the possible paths they can go through? We understand equal cost multipath, all of that. We can take it even a step further. Using flow data, we can even figure out what are the actual links that packets for a specific flow went through. So, but that's the answer to your question.
Okay. Yeah, that's really interesting. So let's jump to from a network operator's perspective. I want to be able to see where I have issues in the network, and not only be able to go in and see, but like you mentioned, get alerted. How does the typical network operator, network administrator, network operations center, how do they leverage Augtera on a daily basis? Are they typically in there proactively, or do they have alerting set up so well that they really only need to get involved when there's an issue? What does that typically look like?
Yeah. So, see, our customers want to move away from this world where someone has to stare at a screen 24/7. Because you look at large enterprises, large providers, they sometimes have armies of people staring at screens, right? So, the way our customers are consuming Octera notifications is ServiceNow, ticketing platforms, which are automatically consumed by NOC, Slack, or Teams, collaborative filtering platforms where you get the notification, and that notification then, of course, ends up in someone's Slack channel, syslog. So the syslog notifications often feed auto notification pipelines which exist, or email, and so on and so forth. We can also notify over Kafka. So it's really this paradigm where all the examples I've given today, right? Congestion, latency, application loss, optics, and so on and so forth. Misbehavior in these, it triggers notifications which humans then consume, and then they come to Octera to start doing deeper troubleshooting. We have a very comprehensive UI, but they don't typically use our UI as a destination on a day-to-day basis. It's more based on a automated workflow. Um, the other way our customers consume our product is when they get a notification, their software goes and drives a change in the network. So let's say that there is a link in the data center flapping. It's much better to take that link out of service than to actually leave it the way it is, because there is so much equal cost multipath that you don't really want any packets to go over it. So there are customers who take our notifications in their automation pipelines and drive changes back to the network.
Okay, that makes a lot of sense. Yeah, to be able to remediate those issues without even somebody have to getting involved. I can see that being very beneficial, and that's pretty impressive. So back to kind of starting from day zero, what for a customer, what would be the initial effort to get Augtera up and running, and what does the care and feeding look like once, let's say I'm back to that enterprise use case, I've got my Augtera VMs stood up. What does it take for me to get it configured, and how much, once I'm ingesting data from all my different devices and points in the network, how much tweaking am I having to do to these alerts, or do you have it to where pretty much anything out of the box is going to get you going a long way right away?
Yeah. So 70% of our customers use Octera software as a service, our SaaS. 30% of our customers are fully on-prem. So let's take both those scenarios to answer your question. For our SaaS customers, the deployment is actually very straightforward. They need to deploy an Octera collector or a set of collectors which take data from their infrastructure, whether it is SNMP, Syslog, Sflow, Kafka, all the things I talked about. This collector acts as a proxy, and then in a secure manner, it sends the data to the Octera cloud. Deployment of this collector is very straightforward. Sometimes customers do it themselves. Sometimes our support team gets on the phone with them, does it over whatever, an hour or so. This collector is set up. They open up some firewall rules. Sometimes they don't even need to, so that the collector can get the data. Maybe they push a couple of config changes. Let's say they're using Splunk. They can point the syslog to it, and so on, right? Now, once the collector gets the data, it pushes the data to Octera Cloud, and the customer, really all they have done is deployed a collector, and then our you can say our teams who are onboarding the customer, they train the customer on the configuration that they can do to customize the second question you asked, right, about customize and tailoring the anomalies they're getting. Are they getting TCP anomalies, for example? Do they really care about TCP congestion? Do they care about loss? So there is an onboarding session in which the customer uh, really expresses what's most important to them. And based on that, our team spends some time, trains them. Software ships by default with all sorts of different, you can say, anomalies and configurations supported. It's just a matter of enabling the ones that the customers care about. So they go off, they enable it, and boom, now they're starting to get machine learning anomalies. There is no configuration at all to tell the software what the baseline is. As you know, people use the word baseline a lot in the industry. It's sort of a overloaded word. In the Augtera case, we learn from the patterns. So it's a very, very low touch. Now, in large enterprise environments, there can be cases where the customers do need to do some customization. Maybe there are metrics that they have in their data which are not standard. Maybe they want to tweak the notifications. Maybe they want to tweak the what they consider operationally useful. Maybe one operator says, I care about packet drops only when they happen on spines, when they are anomalous. Another operator might say, I care about anomalous packet drops even on top of rack, just because my application is so very sensitive. So all those things they can configure on their own in a UI, and there is a training. There is very comprehensive documentation. So I would say for a lot of our customers, it's very low touch. They can spend more time if they want to be highly customized. And if all of this was deployed fully on-prem, the only difference is the customer now needs to manage that on-prem stack. Just like any enterprise software which is on-prem is actually functioning and behaving correctly, it has all the right instrumentation. It gives them all the right alerts. But yeah, they are responsible for that at that point.
So let's, at least at a high level, talk about some of your customers. Is there a specific industry that you see a bulk of your customers, or are you really cross industry? There's a lot of different types of customers out there.
Actually, we have been both fortunate, and also I think we are really proud of the progress we have made across verticals. We've got very large scale deployments in retail, and a lot of most of these are Fortune 500 in retail, in finance, across providers, across managed service providers, and different types of financial companies, technology companies. So I would say, really the common theme is anyone who has a network which is important to them, whether it is hybrid, whether it is fully private, or well, actually, the very few large enterprises, I don't know of anyone, in fact, which has a completely public network, right, or completely in the public cloud. It's mostly hybrid. So I would say that anyone for whom network is important to the business is a really, really good candidate to use our software. And often that's very small providers or very small enterprises. It doesn't have to be someone very large. So you've got a range of customers in all sorts of different verticals and industries who are using us, and using us at sometimes at very, very large scale, tens of thousands of switches, or sometimes small scale, hundreds of switches.
And you mentioned hybrid networks, industries that may have workloads in both private and public clouds. Is that a fairly easy endeavor from an Augtera standpoint to have collectors on-prem and then also be monitoring networks in the public cloud as well?
Yeah. And actually, there are many ways to do it. We've also can take data directly from public cloud, for example, S3 buckets or Google Stack Driver. So we can take data directly from public cloud in many ways. Actually, VPC flow logs is a good example. So we've done a fair bit of work, and we'll continue to do more and more to make those integrations easier.
Oh, that's excellent. So we've been doing a lot of discussion around, what I'll say the main use case here is is how do we better operate our networks? How do we automate troubleshooting, which is huge, that it seems like you're doing here at Augtera day in and day out. Do you see any other use cases outside of just the straight network operations management and maintenance? Do you have any organizations that are leveraging Augtera as, for instance, like a security play or anything else outside of just straight network operations?
Yeah, that's a really, really good question. So our genesis and our focus is all around network operations. The platform we have built and the algorithms we have built often have a much broader scope. And as a startup, we made a very conscious decision to stay focused. What we are finding is that as our customers use us more, they find more and more use cases. So we have a lot of customers who are using us for network security. So for example, we can find things like TCP SYN floods because we're looking at packet data. And TCP SYN floods could be because of an attack. We can find distributions which indicate some sort of a DDoS issue. We can find rare logs which might indicate a security issue. So clearly, there are a whole slew of use cases beyond network operations, which are emerging, and more will emerge. Network security is one, application is another one. Our customers are telling us, well, what if we give you application data, really application metrics, for example, stock ticks, and tell us if there is a misbehavior in my specific application metric? We can do that because we can take, as I mentioned to you earlier, we can take JSON data and we can extract metrics from that in real time. So we are finding more and more use cases emerge, and we'll see us doing more with security, with applications over time. But we continue to be very, very focused around network operations, right now.
Again, I don't want to make you feel like I'm trying to have you talk about the secret sauce, but I do want to discuss the AI concept behind this. I think artificial intelligence can be kind of a nebulous term and maybe mean different things to different people. Can you at least at a high level tell us what AI means to Augtera?
Yeah, absolutely. I think that's a very reasonable question. I think at a high level, there are many parts to this, right? One part to this is that Augtera has, you can say, a fundamental belief that for the network domain, and actually it applies beyond the network domain as well, but for the network domain, the software needs to be able to learn from the data. That you can't actually expect humans to tell you what's normal, what's abnormal. Now, if you think about that gets into the some very core differentiations when it comes to machine learning around supervised, unsupervised, because the different approaches which get into whether you expect someone to tell you what's normal or whether you learn from the data. So we learn from the data, we learn from patterns. Well, then you have to ask yourself, well, when you learn from patterns, well, how do you do that? Because there are literally so many different patterns, and one algorithm cannot actually satisfy all patterns. So we have multiple algorithms for different distributions, for different patterns. And we have figured out, which algorithm to use when. And there's a lot of secret sauce there. It's not easy to do because you really need to purpose build algorithms for certain distributions. And a lot of our algorithms are very network specific because they apply very specifically to network data. And some of our algorithms are beginning to have broader applicability because it just turns out that those distributions, they exist outside the network as well in other domains. So I think that's one part of it. Second part of it is we also understand that when the machine finds results, they need to be operationally useful. And to make them operationally useful, you need metadata, you need context. So I gave an example earlier around spines and top of racks. It could be around different data centers in different geographies, different VPCs. So we do a lot of enrichment of the data to make it easy for the operator to mine the data. So that's another belief we have, that AI is a tool, but you need to marry it with a lot of rich context from the domain to make it operationally useful. And we have done that in the networking domain, in a very, very deep way. And we also learn the models of the networks and the topologies of the network. The Other thing is that there are cases, and I won't get into it, it gets a bit into secret sauce, where we do learn from the operator what the operator thinks is uh, is a real issue, and we can do that collective learning across operators. So let's say one example I can talk about is if we our machine learning can learn, as I mentioned, using logs, that there is a unique log for ASIC parity error on, let's say, a Cisco or a Juniper or a Arista device on a specific OS. We can transfer that learning across our customer base. So now, if we learn that pattern in one network, we can actually leverage that in another network. We call that collective learning. Um, so, I mean, that's a very unique thing we've got, and that takes a slightly different approach than some of the other approaches I talked about. So, hopefully, that gives you a sense. One more thing I'll say actually, we have another very, very rich algorithm which can do what we call autocorrelation. So, as we learn the topology of the network across layers, and as events take place, let's say you cut a link in the data center, and because of that, the layer 2 flaps, BGP flaps, traffic distributions change. All of this results in different events and, in Augtera terminology, different machine learning anomalies. We can put all this together by using our machine learning algorithm, which leverages the network topology and all the events and anomalies that we find or create into what we call a single incident. So that's another form of machine learning we do. So it's really not one thing, it's many different things. Hopefully that gives you some context.
No, that gives me a lot of context. In fact, I think the whole concept of that issue correlation and being able to take different data from different devices and points in the network and be able to correlate them and call this out and say all of these different things are one single issue. I think that's incredibly beneficial. And you brought something up a minute ago that I really appreciate, but it's not something I really thought about much until you said it, is that you really can't rely on your end users and even on your technical staff to always know whether what is happening is normal or expected behavior. And to be able to have all of those different data points not only being collected and aggregated, but to be correlated and be able to show you, hey, you need to look here because we think we have an issue here. Or, like you alluded to earlier, have automation built into it to where you can have workflows that can remediate whatever it is that it's seeing. I think that's incredibly beneficial, and I'm sure your customers get tons of value out of that.
I think what you just repeated, I want to go back and highlight that this is one of the least understood issues. People don't know what's normal. I think this is the part which often when we talk to our customers, once they understand that, and a lot of them often know it, then everything opens up. Because let's take a very simple example. Let's say I'm a large enterprise, and let's say I have a global network. I mean, it doesn't have to be global, national network across multiple regions, and I have interconnects which I have bought from different providers. And maybe I have my own backbone, but I bought some interconnect from AT&T here, Verizon here, Level 3 here, you go on and so on and so forth. Now, these interconnects, they all have the latency and loss. Uh, and one might be at 50 milliseconds latency, another might be at 70, one might be having 0.01% loss, another 1.02, and that's normal. You have no idea as an operator what is the normal behavior of that circuit. But if you don't know what's normal, how can you know what's abnormal? So the magic of AI is to first discover what's normal and to actually learn from the patterns. And as the normal keeps changing, keep relearning. That's another big thing that we do. So this is not humanly possible, right? Humans can't actually figure this out until they keep staring at screens. And that's a big part of the value that we provide.
Definitely. I can definitely see a lot of value there. I've always been a proponent in, if there's an issue that can be seen through automation, automatically through a network, I want documentation of it. I want that ticket generation but we touched on it towards the beginning of this, and I'd like to dive deeper into it. That is beneficial, but then somebody has to open up their ServiceNow, and all of a sudden they see tens or hundreds or even more incidents sitting there waiting for them, and they don't know where to begin. So can we kind of talk through? I want to talk specifically about your policy-based noise elimination. Can you delve deeper into that?
Yeah, that's actually that's a really good question. So let me maybe start from the other end. So I'll take one of our customer examples to illustrate the power of what we do, right? We, in a very large network, we are getting billions of data points a day. And by data points, I mean, one metric on one interface in 5 minutes is one data point. So we're getting billions or literally tens of billions a day. From this, we generate about 100 or so anomalies using all the different techniques which I've talked about. And of these, about 10 to 15 get ticketed. So this part is very important. Before we came into the picture, in this particular operator, they literally had hundreds of tickets a day. So that's alert fatigue. With the power of all our tech, and I'll take you through a little bit of it, they are getting 10, 15 tickets a day, which is very, very manageable. So I think that's and their mean time to detect has really dropped by almost 90% plus, like 90 to 93% or something like that, right? Which is and also the time to remediate has dropped as a result, but it comes down a lot to much fewer tickets, much more high fidelity, much more actionable. How does that happen? So when we get the data in, one of the things we do is we remove noise from the data, because because of the machine learning, we learn from the patterns, and we only ticket what's actually really a significant change, and we do take operator, you can say, criteria or policy. Use the word policy, which is a good policy, which is a good term. We use the operator policy and take that into account, right? Things like don't ticket anything if it is, for example, I don't really care about any anomalies which are happening with the CRC errors until they're repetitive. That's a good example. I want some repetition to happen. So we have the ability to first, if you go to the older systems, they were very threshold based. So let's say that if you're looking at just temperature or optics or latency, you would say, you know what, give me an alert if latency goes over 100 milliseconds. Well, that's a problem because latency keeps changing. It keeps changing on every circuit. It's different on every circuit. So because of the machine learning, you automatically reduce noise because it's learning from the distributions instead of you selecting a threshold which doesn't really apply all the time to different objects, right? Now, once you have these anomalies, then there is the concept of deduplication. I've created an anomaly on a specific interface on a device. Well, maybe that anomaly repeats itself. You don't want to keep alerting or keep ticketing. You want to be able to either suppress those alerts, or with something like ServiceNow, we can do even better. We can add events to an open ticket. So you create a ticket, and now if that event keeps reoccurring, you keep adding to the ticket. So that's a second technique. Third technique is our autocorrelation. Let's say a link, I'll give you a production example. There is a switch which had an issue. It was a leaf switch connected to 4 spines. That leaf switch had a hardware corruption, and the 4 spines, they started to flap and drop LLDP and BGP sessions and started to give alerts. So you've got 8 alerts coming from these 8 switches. This switch, the one which is misbehaving, is silent. It's not even giving any alerts. Augtera autocorrelation technology put together these 8 into one because we understand the topology. We understand they're connected to this common leaf, and we can autocorrelate. So instead of getting 8 tickets or 8 events, the operator got 1 because we autocorrelated these 8 into one. So that's sort of another technique we have to reduce, the noise or the amount of tickets you get. And I'm sure I've not gone through all our techniques around this. We have a lot of things. For example, finite state machines. which dampen control plane states. So I can go on and on, but there's a lot which has happened to make this happen. So not so easy to do.
I go back to that correlation being incredibly valuable to be able to take those 8 different alerts and really convert them into one incident, because I know I've been in situations where we may have had physical power issues at a site, and all of a sudden we're getting alerts from every single device. And if every single device was then converted into an incident, we now have tons of incidents without, you're doing manual correlation at that point. To have a system that's doing that for you is incredibly valuable, because not only does it drop that amount of incidents down to minimal, but it also de-stresses that operations staff, because when they open up that ticketing system, they're not completely overwhelmed. They're able to focus on the less amount of things that are now on their plate. So there's tons of value there for sure.
Exactly. Yeah.
So I do want to pivot a little bit with the evolution of networks over the last few years, and more companies wanting to use commodity broadband, different types of internet circuits to not only to connect to the greater internet, but to connect to things like public cloud. We have this wonderful thing called SD-WAN. Now, there are a lot of moving pieces to SD-WAN. There's a lot of places where things can go wrong, and a lot of the SD-WAN providers, have their own built-in analytics and can help you point to and correlate issues. But I do have to call this out, because I see a blog on your website about using Augtera to detect SD-WAN network brownouts before there's a failure. Can you pick apart that a little bit for us?
Yeah, we do a lot with SD-WAN. So an example would be, let's say that there is a SD-WAN internet circuit, and that internet circuit begins to either drop packets intermittently, or again, its latency spikes. So we can take data from the SD-WAN providers. Most of them have a fairly good bit of IP fix data. We can also take some proprietary logs from people like Versa, and we can figure out the misbehavior in loss, packet drops, jitter, or TCP retransmits, which tells us, what, the circuit is misbehaving. And we can do it better than those vendors do, because our machine learning of all the capabilities I mentioned, it just actually learns from the patterns. So often what can happen is that SD-WAN itself might, for example, be running on a single leg, because you might have 2 circuits. One circuit has a gray failure. We can detect the gray failure. We can correlate it. We can also point out things like flaps in the control plane. If you've got a lot of flaps going on in the IPsec layer or in the tunnel layer, we can find that. And we can, another thing which is very interesting in SD-WAN is we can connect the dots from the network to the application very quickly. So let's say there is a particular application is starting to see retransmits. Let's say it's Zoom. We can really point out, look, Zoom is seeing retransmits. We can do it automatically. And you know what? It's happening because there are packet drops on this link. So there's a fair bit we can do with SD-WAN.
Now I want to go back to alert fatigue and that kind of situation. So let's say you have a customer that's running an SD-WAN network. The SD-WAN provider obviously has their own logging, their own alerting, potentially their own capability to create incidents in an ITSM, and your customer also owns Augtera. So do you see those customers, are they disabling some of that alerting in the SD-WAN provider, or are they just maybe not generating incidents from the SD-WAN provider's alerting system and they're leveraging Augtera to do that? How have you seen customers handle that?
It's a good question. It's an evolution. What we see is that customers often start by just complementing us with whatever they've got to find issues which other people can't find. That's often a starting point. For example, some of the gray failures I mentioned, some of the correlations I mentioned. As they get more comfortable with our software, yes, our customers do often turn off other monitoring systems, and just rely on us to really feed a more holistic view across the infrastructure. So it's a mix, and we've got customers sort of doing both, and we've got customers who are very comfortable with both. We've got customers who are very comfortable with just using our complementary capabilities and just on top of what exists. Yeah.
No, that makes a lot of sense. I'm glad that you really highlighted that there are definitely transitionary periods where people may leverage both and maybe continue to leverage both or become confident enough that they like what they see, especially in that correlation of issues in minimizing the amount of incidents that get created that they get as a value out of Augtera and really entrust their alerting to that. So that's excellent. Rahul, this has been an excellent conversation. I appreciate you coming on. Is there anything that we haven't touched that you want to dive into before we round this out?
I think it's been a great conversation. No, I think we've had a pretty comprehensive discussion. So I really appreciate you giving us the opportunity to come onto the show and for the great dialogue.
Thank you, Rahul, for yourself and the rest of the Augtera team for supporting the Art of Network Engineering. If you want to check us out, you can find us at artofnetworkengineering.com, at artofneteng on Twitter. Rahul, where can we focus people to go to learn more about Augtera?
Well, Augtera.com, that's our website. It's really one of the best places to go and get information about us. On LinkedIn, we are really, really active, and we've got a great community on LinkedIn. So I would encourage people to join our LinkedIn page as well. I think those would be two good places.
Excellent. Thank you again, Rahul, and to the rest of the team at Augtera. This has been another episode of The Art of Network Engineering. Thanks for joining us. We'll see you next time.
Hey y'all, this is Lexi. If you vibe with what you heard us talking about today, we'd love for you to subscribe to our podcast in your favorite podcatcher. Also, go ahead and hit that bell icon to make sure you're notified of all our future episodes right when they come out. If you want to hear what we're talking about when we're not on the podcast, you can totally follow us on Twitter and Instagram at Art of NetEng. That's Art of NetEng. You can also find a bunch more info about us and the podcast at artofnetworkengineering.com. Thanks for listening.